Hello friends, today we are going to understand the number based system. It's one of the least understood topics in aptitude, and I will make this very simple as much as possible. Once you understand the concept, then you can follow it up with your aptitude book for problem solving. You can also refer to our aptitude book, AptEasy. This book is specially designed for GATE and NET aptitude part. So let's move on to the topic. We mostly write numbers using the decimal system. So whenever we write in the check or any number, when you do the calculations, you all use the decimal system. So when I say 134, that is 134, we write it as 1 into 134, which is actually 1 into 100, right? 1 into 100 plus 3 into 10 plus 4 into 1. So here the 1 is basically in the 100 position, 3 is in the 10th position, and the 4 is in the unit position. So basically we can write it as 1 into 10 to the power 2 plus 3 into 10 to the power 1 plus 4 into 10 to the power 0. Take any number and you can distribute it in this pattern. In the decimal system, the numbers are written using numerals or the symbols, and these symbols are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So these are the the symbols that we use for particular numbers, and with these 10 symbols we create the whole of our numbers, right? So that's why it is called as decimal system. Now we can also create numbers using lesser numerals or even more numerals. So if we create numbers using less numerals, naturally you will have bigger number. And if we create numbers using more symbols, more than 10 symbols, numerals, so more than instead of using this 0 to 9 symbol, if we use in addition to this we use couple of more symbols, then what happens is the number the position the numbers will take lesser space. So it depends what we are doing. For example, in computers we use 0 and 1, so we write all the numbers using the combination of 0 and 1 called binary. So that is a base 2, right? So we'll see how you can write a number in different bases, right? So let's say first we'll see what are the symbols we use for different bases. So for example, if you are using binary system, so we'll use only 0 and 1, right? So only 0 and 1 is used for base 2. And if we use a base 3, you will use 0, 1 and 2. So if we take this forward, if we have base 4, we will use 0, we will use the numeral 0, 1, 2 and 3. Come down like this. If it is base 8, what do we do? 0, 1, 2, 3 up to 7. So whatever be the base, if it is base 4, we see that you are using the numeral 0, 1, 2 and 3. So there are four symbols that we are using. If it is base 8, we are using 0, 1, 2, 3, 4, 5, 6, 7, right? So we are using 4, 5, 6, 7. So we are using again 8 numerals, 8 symbols. and if it is 9, you will use 9 symbols, right? Now we'll see how with these combinations we can write the numbers. So suppose we have a number in base 10 as 1, so we'll represent in base 2 also 1. It's the same 1 1, because in base 2 also we have 0 and 1, right? So before proceeding, I will say that, if you have a number 0 in base 10, it will be 0, it will represent as 0 in any of the bases, right? So it is immaterial, whichever base you use, 0 is always 0. Now in case of base 10, 1 is represented as this by numeral 1. It is again represented in base 2 also as numeral 1. In base 3 also it is represented as numeral 1. In base 4 also it is represented as numeral 1, and base 5 also it's same. Base 10, the numeral 2 that we write 2 is represented in base 2 as 1 0. Just follow it as of now. I will tell you how you will get these values. It's not very difficult to get it, but let's see the pattern, and then maybe you will catch up very fast. So what we normally represent as 2 in base 10 or in decimal system, you will represent it as 1 0 in base 2. In base 3 it will represent it as again numeral 2, because in base 3 you can represent it as 0 or 1 or 2. In base 4 again it is 2. In base 5 it is again 2. Coming to 3, it will be represented in base 2 as 1 1. In base 3 it will be represented as 1 0. In base 4 it is represented as 3. Base 5 it will be represented as 3. Come to 4. In decimal system, the 4 that we write like this with the numeral 4 is written in base 2 as 1 0 0. Here it will be 1 1. Here it is in base 4, you have already exhausted 0 1 2 and 3, so it becomes, it goes to the next value, so it becomes 1 0 here. And here in base 5 it is 4. Now come to 5, it will be 1 0 1 here. Here it will be 1 2. Here it will be 1 1. Here it will be represented as, since you have already exhausted 0 1 2 3 4, so it becomes 1 0. So try to figure it out this way, but I will tell you how to do it, how to calculate, or how to change from one base to another. We'll just look into that also. But now this was the case when we had less than 10 bases. So base 2, base 3, base 4, base 5. Now what happens when you use more than base 10? So we can have base 11, base 12 or base 16 as well. So which symbols to use? So in that case what we do is that we use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 numerals as we use now in decimal system. And then for later ones we represent it as, A, B, C, D, E, F. Meaning A is actually your 10. B is representing your 11, C is representing your 12, D is representing 13, E is representing your 14, and F is representing 15. So if you have a base 11, what we have here, base 11, in that case you will only use A. If you have base 12, you will use A as well as B, and so on. And if you go to base 16, you will use A, B, C, D, E as well as F. So that is the way we represent. So till base 16 it is being done, and theoretically it is possible to extend it further, but generally it is done in these levels only, right? So if we have, say for example, here I should have included 10 as well here. So in base 10, in a base 10, the decimal system, the 10 is represented here. That will become, in base 11 it will be A. In all the bases you will have A here, and if it is 11, in base 11 it will become 10. In this base 12 it will become B, and till base 16 it will become B. If it is 12 in the decimal system, that becomes in base 11 11. In base 12 it becomes C. Oh, my apologies. This will become your 10. Here it becomes C. 13 will become 12 here. Here it will become 1. Here it becomes D, and so on. Now we need to actually do a calculation to get a change from one base to another. So let's do for an example how we'll do for if you want to convert from base 10 to base 2. So what we do is that we do a simple arithmetic. We do 1 3 4. If you want to convert into base 2, we will continue dividing it by 2. So 2 6 are 12, 2 7 are 14. So remainder is 0. Now come here, 2 3 are 6, 2 3 are 6. There is a 1 remainder, that becomes 1. Now again 2 1s are 2, 2 6 are 12, remainder is 1. Then again 2 8s are 16, remainder is 0. 2 4s are 8, remainder is 0. 2 2s are 4, remainder is 0, and then 2 1s are 2, remainder is 0. So this 134 in decimal is actually 1. You have to start from here and go up, so it becomes 1 0 0 0. So 1 2 3 4, 4 zeros are there, and then 1 1 and 0 in base 2. You can see 134 in decimal system had only 3 symbols and numerals, whereas if you represent it in binary, now you have to use 1 2 3 4 5 6 7 8. So 8 spaces are being taken up, because you are representing the whole number in only sequence of 0 or 1. Now see the case when we represent this 134 in base 7. So again here what you do, we will again do the division by 7. So what we get, 7 1s are 7. I have a remainder of 6. So it is 7 8s are 56, right? 7 8s are 56. Then I get a remainder, 7 9s are 63. My apologies. So it becomes 7 9s are 63. 1 remains. 7 2s are 14. 7 2s are 14, and then 5 remains. So the number is basically 134 to the base 10 is nothing but 251 to the base 7. So this is how you can convert from base 10 numbers, the normal decimal numbers that we have, into any other base. So what you have to do, the simple formula is just divide that number by that base and follow the pattern. So as long as you go from here, and you know, in each division you take the remainder. If the remainder is something, you write it down. If the remainder is 0, then also you write it down, and then start from the lowest one and then proceed upwards. So here it is, for example, in this case of base 7, it becomes 251. In this case it becomes, in case of base 2, it becomes 100000110, right? Now this is the one side. Now the other way, if you have some base other than decimal and you need to convert it back to your convert back to decimal, then we can do the reverse. In this case, what we do is that, suppose we had base 2, this is 1 followed by 4 zeros, 110, right? So what we do, 1 followed by 4 zeros and then 110. So now what we do is that, remember we discussed this one, that in decimal we represent it, basically the numbers are 1 into 10 to the power 2 plus 3 into 10 to the power 1 plus 4 into 10 to the power 0. So here what we'll do is that we'll represent it as a sequence of powers of 2. So this is having 0 power, this will have 1, this will have 2, this has 3 power, this has 4, this has 5, this has 6, and this has 7. So basically I can write it as 1 into 2 to the power 7 plus, I ignored the 0 ones, so I just jump to here, then it becomes 1 into 2 to the power 2 plus 1 into 2 to the power 1. That's it, because this is also 0. So I can represent 2 to the power 7 is how much? It is 128. 2 to the power 4 is 4, and this is 2. So 128 plus 4 is 132 plus 2 is 134. Here base 7, the number was 251, right? So we had 251 to the base 7. So this can be again converted, this we converted back to 134 as decimal. You can represent now. So now how we will convert this in from base 7 to base 10. So here also you see this has power 0, this has power 1, this has power 2. So we can write it as 2 into 7 to the power 2 plus 5 into 7 to the power 1 plus 1 into 7 to the power 0. Now this is 2 into 49 plus 5 into 7 plus 1 into 7 to the power 0 is 1. So it is 1 into 1. So now this is how much? This is 9 to the 18. So this becomes 98 plus 35 plus 1. How much this is? 8 plus 5, 13 plus 1, 14. And then 9, 3, 12 plus 1 carried is 134. So this is the way you convert back to decimal. So now you can understand how we can do these things. Now suppose we have one example. Let's take the GATE 2010 question that came. So the question was that if 137 plus 276 is 435, then how much is 731 plus 672? Now first of all, you will check it out whether this is in if this part is not given, if the question doesn't say if in some base system, then how do we make out whether it is a different base? So what you will do, First of all, you will try to check it out in decimal system whether it holds or not. So 137 plus 276, if it were in decimal, how much it will be? 7 plus 6 13, 7 3 10 plus 1 11, 2 3 413, right? So what we can see is that first of all that this addition in decimal is giving 413, whereas actually we are getting here 435. That means it is not in decimal. Further, since you can see that the number that we are getting in either this in different base, the addition, the number is bigger than this one, which shows that the values are such that it is in a lower than base of 10, isn't it? Because as we saw earlier also, if a number is in base if number is 134 in base 10, if we convert it to base 2, you see it will occupy a larger space. Okay, and here also base 7, you see 134 is represented as 251, although the space taken is same, but here the number looks bigger, isn't it? Because it's of a smaller base. So from this we can easily make out that this is less than base 10. Now let's see which are the numerals being used in this system. So we can see that it has used 1, it has used 2, 3, 4, 5, 6, 7, isn't it? It has used 1, 2, 3, 4, 5, 6 and 7. So naturally, if you add 0, so it has to have at least, it should be base 8. Since it is not a decimal, so it can be either base 8 or base 9. Only two possibilities are there, because why it cannot be base 7? Because we have in base 7 you would have only 0, 1, 2, 3, 4, 5 and 6 and not 7, right? So this is base 8 or base 9. Let's proceed with base 8. Now check simple we will do a simple addition. We'll see that 7 plus 6, if it is 7 plus 6, how much it becomes? 13. So 7 plus 6 will be 13 in any of the base 8 or base 9, right? So if this 13 is there in base 10, how much it will be in base 8? See, in base 10 and base 8, let's write the numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now 1 in base 8, it will be 1, 2, 3, 4, 5, 6, 7, and then it becomes 1, 0, then 1, 1, 1, 2, 1, 3, 1, 4 and 1, 5. So it will become 1, 5 in base 8. Yes, it's matching because we have 5 here. So definitely this means that this addition is in base 8. Now if this be the case, now look at our this problem. So 731 plus 672. So 2 plus 1 is 3. It will be simple because 3 can be represented in base 8. Now 7 plus 3 is how much? 10. Now 7 plus 3 10 will be actually 7 plus 3 10 will be actually your 12 in this system, right? In see this 7 plus 3 10 in base 10 is equal to 12 in base 8. So I will represent it as 12 here, 1 carried. Now what happens? 7 plus 6, 13 plus 1, 14. Now what happens if I write 14 in decimal? So this becomes your 14 here, and this will become your 16 here. 14 in decimal 10 is equal to 16 in base 8. So this becomes your 16. So this C is your answer. So thank you so much for this, for listening to me. We will come up with another video. I hope you liked this video. Please share your feedback with us on our email support@aptc.in. Thank you so much.